What other kind of key architectural changes should, to drive this AI level scale and operational efficiency, should we be thinking about moving forward?
Three things. One is just picking up on Brody's theme on the amplifiers and the multi-rail, and something I said earlier. It's ripe for innovation inside how we do amplification, optical amplification. And you mentioned it, bro. The huts are a problem. Can you imagine, right? We never would have thought that many years ago, right? So there's more revolution required inside amplification that has to come. Two, I touched on it before, fiber. Sacred, historically people put it in the ground and never want to touch it. With this level of expansion and scale, they're happy to fill conduits and pull old fiber and put the new stuff in if it gives them an advantage, right? And that's why I mentioned earlier, innovation around hollow core fiber is really attractive. Not just the original allure was latency. Of course, it's light travels faster in air than it does in glass. But the kinds of losses we're seeing now that are being reported are making it very attractive. And with that, of course, drives innovation back on the transceivers. Because if the medium's different, what else can you do with the transceivers? What else can you do with the amplifiers? So that's also very exciting. The last thing I'll say, Rebecca, is cooling. The biggest challenge is not all these photons and high-speed electrons and everything, is getting the heat out of these products that we're developing. And we're using absolutely state-of-the-art technology, 2 nanometer CMOS-based devices, but there's still a need to get heat out of these very small spots. And it will open a new frontier of how to better optimize the designs to handle this insatiable demand for capacity.